Here in California, for those folks that have lived out here for a while, we're used to extremes on one end or the other with respect to our precipitation. So here in California, we have more variability in our year-to-year precipitation than anywhere else in the country. For example, in a given year, the normal precipitation, and by normal, I mean the average precipitation in the Sierra over the course of all the 100-year record is around 50 inches. But you can see extremes from one year to the next of maybe 30 inches one year and upwards of 70 to 80 inches the next year. Another location, say Houston, Texas, for example, they also receive about 50 inches of rain, but their variability from one year to the next is roughly plus or minus 5 inches. Whereas here it can be plus or minus 20 to 30 inches. So we see a lot of variability from one year to the next, and that's that idea of whiplash. And here at the agency, we're always preparing for the worst and hoping for the best with respect to our precipitation. You might have heard this in the past. Back in the 90s, we were calling this the Pineapple Express. It's the same thing, but it's a river of moisture that gets scooped up from the subtropics. And as the storms come across the Pacific, they bring that moisture into the state. And this is the main driver of our precipitation throughout a given year. So the more atmospheric rivers we have that eventually go across the Pacific, run into our mountain ranges, that air gets lifted up and the precipitation is more or less squeezed out. That determines whether or not we have a wet or a dry year. Now, normally we see about 8 of these a year, 8 strong to extreme atmospheric rivers, and they are ranked in terms of their duration over a given area and the amount of moisture they have. In the past couple of years, we've only seen upwards of 3 or 4, and that's a little bit unusual that we're seeing this consistently one year after the next. They're just missing us. So here's another animation showing some of these atmospheric rivers moving across, and you can see it scooping up moisture all the way from Hawaii. So it's interesting when you look at this because our weather, even though we're here in California, it's determined by events that are happening all the way down in the subtropics. And if we get a lot of these atmospheric rivers, it can actually tip the scales the other direction and lead to floods. So that's why California is so unique across the United States in terms of its precipitation because of these atmospheric rivers. There is a lot of planning that goes around how much water we get throughout the wet season, which typically runs from about October through May. And the key now that we're trying to figure out is how much of that snowpack is eventually going to make it into our reservoirs. And that brings up the question about the snow surveys. And that's an integral part in our planning as we go through the warmer months and that snowpack starts to melt and makes it into our reservoirs. So the way we do that is we actually have to send folks out on the ground to make these measurements. We do this about once a month, 4 times a year across our 4 snow courses here at PCWA. And what they do is they head out to the field and they, you may have seen this in some of the news reports, but they take a pole and they shove that pole into the ground. And of course, we're all interested in the depth of the snowpack, but what the reason that we're doing these core samples is for is we take that snow and then weigh it. And what that tells us with a little bit of math is how much water is contained within the snowpack. So you see them making the measurements there. And some snowpacks, we might have a snowpack that's 40 inches deep, but there may only be about 4 inches of liquid water contained within that depth. And that's eventually what we're expecting will move down the mountain and make it into our reservoirs.
I've noticed and I've read that you take several samples at each point. It's not just a poke it in the ground and then leave after you measure it. So how long does this take? Is it a day, an hour? Or how long does it take you to do these samples?
Yeah, when we watch those videos, it looks like it's a pretty simple process of just sticking a pole in the ground and measuring, but it actually can be very difficult at times. Sometimes you can hit through ice layers, and that would be a layer of ice that formed from maybe a previous snowstorm that melted. And you want to take lots of samples because the wind after a snowstorm occurs can actually blow snow into drifts. And you don't want one single measurement to dictate your final measurement for a given snow course. So we might take upwards of 10 measurements at a given snow course, make all those assessments of how much water is in each core sample, and then average that out. And that gives you your final value for that particular course. And of course, we also will do some different samples at some maybe higher elevation courses to give us some information on how much snowpack is available at these higher elevations, which is typically a little bit deeper than the lower elevations. You may remember back in late March of this year, we had another record that was with respect to temperature. So we had those record high temperatures, and that melted a lot of the snowpack at the lower elevations. So yes, there's a lot of effort that goes into this. It's not something that's a quick one and done, and then you're done for the day. It can take quite a while. The April 1st reading is very important simply because by that time, you've acquired pretty much the maximum amount of snowpack you're going to get in a year. And the theory is that as these snowstorms occur, you're just going to pile the snow on top of each other. And by April 1st, that's about the time that most of the snowfall for a given year has come to an end. And at that point, you're going to start melting that snowpack, and that's going to make it into the reservoir. So once we make that measurement in April, it gives us a pretty good indication on how much water we can expect to run down the hill and into our reservoirs during that melting season. A lot of things can happen with the snowpack. If you've ever seen an ice tray in your freezer, you might put the ice in the freezer and then 5 months later come back and a little bit of that ice is gone, and you might wonder, well, what happened? Some of that ice can actually evaporate. It's called sublimation. The same thing can happen with the snowpack. It may not soak into the ground, but it can actually evaporate. And so why we're making these measurements throughout the year is to see what that snowpack is doing. And the assessment that we're doing in April is suggesting that, we have about, say, 4 inches of water within that snowpack. Not necessarily all of that will come down the hill, but we're assuming based on some calculations that we can do, we can get a pretty rough estimate on how much of that water will make it into the rivers and eventually into the reservoirs.